Now, I'm sure everybody knows what a pantograph is. I mean, it's just an arrangement of basically 4 sticks arranged in a diamond pattern. It's actually a parallelogram, and it's used to shrink up or scale down original drawings. And it only really depends on how long those sticks are to whether it scales up or scales down. I mean, these days, of course, we think of it more of a child's toy, but there was a time when the pantograph was a dearly kept industrial secret, because it allowed artisans, artists, sculptors, masons, those kind of people to do something in a matter of a few minutes that would take a skilled person hours to do. So it was a closely guarded secret. And there's this apocryphal story that a guy called Christoph Scheiner in 1602 wanted to know how this was done. He'd come across it, he'd met a guy in a pub, seriously, he'd met a guy in a pub. The guy had boasted about this, but wouldn't tell the secret. Presumably because, you know, this was a guild system and he was afraid of getting hung, drawn and quartered. But this upset Christoph Scheiner, and he worked out how to actually make a pantograph, and the secret was out. After that, of course, they were used quite a lot, and they have their limitations. They're kind of wobbly. You do need a degree of skill to actually make it work properly. And it was a mathematician, William Wallace, and this is not of Braveheart fame. I mean, he was Scottish, but he wasn't a warrior with a blue face. He was a mathematician. And in the 1800s, he improved it in something called the idograph. He went to the bare bones of it, moved the pivot point to the centre, and worked out mathematically how that parallelogram could best be achieved in a compact device. And there were some lovely examples made, some beautiful ones out of brass in various museums, but of course it was now a precision instrument used for things like engraving and coin making and all kinds of stuff. It was expensive. So the idograph has kind of fallen into obscurity, and the pantograph has kind of become a toy. But I was looking at this, and I really like the idograph mechanism, particularly because I was looking at continuously variable transmissions, and I thought, you know what, I'm just going to make an idograph. And I thought it might be interesting to people if anybody's got a 3D printer, an artist in the family, an up-and-coming birthday or a Christmas present, they might want to reproduce this, what is essentially accurate instrument, to aid in that enlarging or shrinking down of drawings. So I thought I'd give it a go. And this is what I came up with. Now, the whole thing was put together from primitives. So you're talking about cubes, cylinders, cones, and that's it, apart from the threads. The threads actually got by going to the search bar, typing in thread, and up will pop something called ISO thread, and then you can just adjust that to how you want. And of course I cut the sides off so they would fit into the slot. Okay, let's get that printed. Now, in the original they used wire, and to be honest I didn't want to do that because I like it when things are totally 3D printable. So I created this 3D printable chain link, and you print off 58 of them and then link them together, and they just snap together like that. And you snap 58 of those together to get a long chain, and then you join the ends of the chain by snapping it together. And what you get is that. Then we take the arm and this screw here, or bolt if you like, and it goes in like that and screws into this projection. And you'll notice there's a circle put here at the end of the slit. That acts like a clamp. So the pencil or pointer drops in there, we tighten this, it'll clamp it up, and that means we don't get any stress points at the end, and it acts like a little spring. And these bits are the clamp piece. There's a gear there that's got a projection that will feed into the main arm, and you can see that there's a rectangular slot in there. That rectangular slot fits in there, and that goes on like that. Now, it will be a tight fit and you need to glue it in, so give it a jolly good press and it'll go in there. The shaved off screw goes into that slot in the centre there, and then this is a clamp plate that goes on the top, and that bolts onto the clamp plate to hold everything in place. So that when we feed the arm on and tighten that down, it's held in place, but that means it's free to swivel in that direction, and the pencil and pointer go in the end here. Right, when you've done that, stretch the chain between two of them, lift them up and put them into the holes in this central arm, and just feed them through the holes. then when you've fed them through, there's a couple of clips that go on to hold them in place. So it's like that. Now if we turn one of them, then the other one turns by the same degree because they're tied together with this chain. When we've done that, we can put the arms back on, one pointing toward me and one pointing away from me. So when we move them, of course, they're in a parallelogram, so they move the same degree because they're tied together by that chain in a parallelogram. Now all we need is the central pivot point. Right, the central pivot is put together in the same way as the arms. It's got the cut-off screw which goes in the centre there. Then when it's put together, that will go on, and then that will go on there to hold it in place. And this central bar is what will feed through here. You might notice it's actually a cylinder at the bottom, and that goes through this cone foot stand, and then there's a clip that clips onto the stand. And I put a pointer in there and a pencil in there, and that's the whole machine finished. Now, clearly these arms, this arm, can move up and down in that direction if you loosen that bolt. Once you move that, of course, it's a lever. So a small movement of this in that direction will lead to a large movement in that direction. And that's where it gets its ability to enlarge from. Equally, if you move it right the way down here, so the pivot's up here, a large movement in here will give you a small movement down, so you can reduce it. In the centre, it will just straightforward copy. And of course, the same goes for these arms, which means in the X and Y direction, then we're able to both reduce, enlarge and copy drawings using this. And it's really pretty neat. And of course it does fold up nice and neatly. If we swivel that round, loosen these off, we can actually slide that all into one and put that in one case. But let's have a look at it copy. Now it works best if the pencil is in constant contact, and for that it doesn't hurt to add a few weights. And here I'm just using ball bearings because they fit on the pencil rather nicely. And if I hold the foot and move my pointer to the start of the actual square that we've got, the small square, and we follow the lines of the small square, then we can actually get an enlarged copy of the square there. So there you go, one working Eidograph. Now of course I'll put these files onto Thingiverse should anybody want this or want to play around with it, because it will be stunningly easy to modify. If you want to modify it, all you're actually doing is increasing the length of these arms. If you make these arms longer, then your range is going to be, well, so much better. There are other things you could do. You could, for instance, add little runners or rollers under here to help support this, because at this point it's not too bad. But if you make these super long and you're right out here, you're going to find that wobbles a little bit. But you could put an extension with a roller and that would stop that wobbling and give you a great deal more accuracy. So there's an awful lot you could do with it if you wanted to modify it yourself. But as a little tool, a drawing tool, it really, I think, is pretty cool. I hope it's useful. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.